Hey everyone! Welcome back to another thrilling dive into the world of theoretical physics. Today I'm going to unlock the mysteries of the Alcubierre warp drive, a concept that just might make faster-than-light travel possible. First off, let's talk about general relativity. Einstein's theory tells us that gravity isn't just a force, but a curvature of space-time caused by mass and energy. Imagine space-time as a rubber sheet. A heavy ball placed on it will create a dip, and smaller balls will roll towards it. That's gravity. Now, here comes the juicy part. The warp bubble. Picture a spacecraft inside a bubble of flat space-time. In front of the bubble, space-time is contracted, and behind it, space-time is expanded. The spacecraft doesn't actually move faster than light within this bubble. Instead, the bubble itself moves through space-time, transporting the spacecraft faster than light from point A to B. Cool, right? To explain this mathematically, we use something called the metric tensor. The Alcubierre metric modifies space-time by contracting distances in front of the bubble and expanding them behind it. The formula looks like this. ds squared equals sine c squared dt squared plus dx vst frs dd squared plus di squared plus dz squared. Here, ds is the space-time interval, c is the speed of light, t is time, x, y, z, are spatial coordinates, vsrt is the velocity of the warp bubble, and frs describes the bubble's shape. But here's where things get tricky. The creation of a warp bubble requires exotic matter with negative energy density. In classical physics, negative energy doesn't exist. However, quantum field theory gives us a glimmer of hope with phenomena like the Casimir effect, which can produce small regions of negative energy density. And then there's the energy requirement. It's colossal. We're talking about energy on the scale of a planet or star to create and sustain a warp bubble. Definitely beyond our current tech. Stability and control are another can of worms. Even if we had the exotic matter, keeping the warp bubble stable and under control is a massive challenge. Theoretical models suggest it could collapse or behave unpredictably, which would be, well, not good for anyone on board. Faster-than-light travel also messes with causality, potentially allowing paradoxes like traveling back in time. While the Alcubierre drive avoids locally violating the speed of light limit, the broader implications for causality are still a big question mark. But let's dream big for a moment. If we could harness this technology, interstellar travel would be within our grasp. Journeys to distant star systems could become a reality, opening up new frontiers for exploration and colonization. Beyond that, it could drive advances in energy, propulsion, and material science. In the end, the Alcubierre warp drive is a mind-bending exploration of the boundaries of our understanding of physics. While it remains speculative, it fuels our imagination and pushes the limits of what we think is possible. Who knows? Continued research might one day bring us closer to the dream of interstellar travel. Thanks for tuning in. Don't forget to like, subscribe, and hit that notification bell for more mind-blowing science. Until next time, stay curious.